Students of 11th class, I am Pardeep Koul, lecturer in chemistry, and we are continuing with thermodynamics. And today's topic for you in thermodynamics is first law of thermodynamics. As you know, in this unit, we are learning energy changes during a reaction. During a process, when a system changes from one state to another, when it changes its state, when it goes from one form to another. So this law, that is the first law of thermodynamics, this law is basically an energy law. This is energy law. Energy law. This law says that energy can neither be created, nor destroyed. However, it can be transformed from one form to another. You might have read this definition in lower classes also, that energy can neither be created nor destroyed. However, it can be transformed from one form to another. In lower classes, you might have read a law known as law of conservation of energy. Law of conservation of energy. So that law, whose definition is this one, that law, that is law of conservation of energy, and the first law of thermodynamics, they are one the same thing. That means basically first law of thermodynamics is the law of conservation of energy. As I earlier said you, that this law, first law of thermodynamics, it pertains to energy. It is an energy law. So this is law of conservation of energy. What does this law states? This law states that energy can neither be created. You can't create energy. And if you can't create it, you can also not destroy it. However, you can transform it from one form to another. I will give you a series of examples later on, but this is the main statement of first law of thermodynamics. We can state this law in many ways, but before going to those ways of defining this law, of stating this law, let me tell you that this law, that is your first law of thermodynamics, it was proposed and given by a scientist whose name is Helmholtz. Helmholtz is the name of the scientist who gave the law, this law, that is first law of thermodynamics. Helmholtz gave this law, that is the law of first law of thermodynamics. Now, since I just told you that this energy, you can't create it, and similarly you can't destroy it. So it also means that energy of system plus energy of surroundings is always constant. This is another statement of this law. Which law? The first law of this and this means the same. That means if we have a system and the remaining part of the universe will be then surroundings. So the energy of system and that of surroundings, that is always constant. Or we can give one more statement. So this is one statement of this law. This is second statement of this law. We can give another statement of this law, that the total energy of the universe, that is constant. You can't add energy to the universe. You can't subtract energy from the universe, because whole universe has a definite amount of energy that you can't change. However, you can transform it from one form to another. So total energy of the universe, total energy of the universe is constant. Similarly, let me give one more statement of this law, that is first law of thermodynamics. We can't construct a machine which can work without using any energy. It is not possible to construct a machine which can work without using any energy, and such a machine is known as perpetual motion machine. What is a perpetual motion machine? Perpetual motion machine is a machine which can work, or which should work, without consuming energy, without the use of energy, and such a machine cannot be constructed as per the first law of thermodynamics. So it is not possible. It is not possible to construct a perpetual motion machine, that is a machine which can work without energy. It is not possible to construct such a machine. This is another statement of this law. These all statements are one the same thing. We can put one more statement here, that is, suppose, as in the first definition I told you, that thou we cannot create or destroy energy, but we can transform it from one form to another. So that means if a certain amount of energy, suppose, disappears, so it is bound to appear. It is bound to reappear in the next instant. That means you cannot destroy it. Now it seems in the first instant that the energy has disappeared, but after some time it will reappear. So the amount of energy that disappears during a reaction is equal to the amount of energy that reappears. So what does it mean? It again means that you cannot create energy, nor you can destroy it. So these are some of the statements of first law of thermodynamics. Now let us give some examples of this law, and I will take some examples where we will discuss the conversion of energy. For example, we make use of this energy. All of you know we use electrical energy. And when electrical energy is converted into light energy by means of electric bulb, so this example shows that one form of energy can be changed into another form, and electric bulb is a live example of this conversion. So energy has converted, energy has transformed but it has reappeared. So electrical energy is consumed. It has been disappeared, but at the very next moment that energy again appears, that is light energy is formed. Similarly, electrical energy can also be converted. Electrical energy can also be converted into heat energy. For example, we use heaters. Which energy is consumed in heaters? Electrical energy. What energy is appeared? That is heat energy. So one form of energy has converted into another form. Similarly, we have a dry cell. Dry cell. You might have seen a dry cell that you use in your transistors. Dry cell has energy. Which type of energy it has? It has chemical energy. Chemical energy. Now, when dry cell is put in your transistor and you switch on the transistor, what happens? Your transistor works. What is your transistor? That is a machine. So what type of energy does it have? It has a mechanical energy. So which energy has been converted? Your chemical energy has been converted into mechanical energy. Similarly, we have diesel. We have petrol. We use these in automobiles, and these fuels, they have chemical energy in them. When these fuels having chemical energy, when they are used in automobiles, what happens? The machine of automobiles runs, that is, it is converted into mechanical energy. So these are some examples where energy conversion has taken place from one form to another form. There is no example in the universe. We can't give any example where we can say that energy has been consumed but no energy has been formed. It is always important that if energy is consumed, it will definitely reappear in the other form. So this is your first law of thermodynamics. Now let me give a mathematical expression for first law of thermodynamics. Now suppose I have a system. Suppose this is a system. This is a system. And it has certain amount of energy, say U1. What is U1 now? U1 is the initial energy of this system. Suppose it absorbs Q amount of heat. Suppose it absorbs how much of heat? Heat is energy. U1 is again energy. U1 is the internal energy. So it absorbs, on absorbing Q amount of heat. What is heat? Heat is again energy. So what is the total energy of the system now? What was its initial energy? It was U1. How much amount has been added to it? Q. So now the total energy of this system will be U1 plus Q, since Q amount of heat has been absorbed. And now suppose work is done by the system. Suppose W is the work done. W is the work done. If W is the work done, now what will be the internal energy of this system? That internal energy will be U2. What is U2? U2 is the final internal energy, and it will be equal to U1. What was U1? Initial energy of the system, internal energy of the system. What amount of heat it had absorbed? Q. How much work has been done? W. It will get added. So the internal energy, that is the final internal energy of this system, will be U1 plus Q. Q is the amount of heat it absorbed, and W is the work done. So the sum of these three will give you the final internal energy of the system. Rearranging the equation, it will be U2. If we bring this U1 to the left side, it will get negative sign. It will be U2 minus U1 equal to Q plus W. Now U2 minus U1 is change in internal energy, delta U. It will be equal to Q plus W. So this is the mathematical expression. This is the mathematical expression for change in internal energy. That is Q plus W. And this is the mathematical expression for first law of thermodynamics. Now, if work is done by the system, suppose in this case work was done on the system. If work is done by the system, then only one change is brought, that this plus sign gets negative. So then delta U will be Q minus W. So this is again first law of thermodynamics. This is in case work is done by the system. This is in case if work is done, this is by the system, work done by the system in case of that, and this is on the system. Or if we rearrange this, we can determine Q. Or Q will be equal to delta U plus W. Now, these two are mathematical expressions for first law of thermodynamics. Now, let me move to some sign conventions. Sign conventions. This is for Q. If Q is positive, that means system has absorbed energy. System has absorbed energy from the surroundings. System has absorbed energy from the system, from the surroundings rather. So when Q is given positive sign, when it is absorbed from the surroundings. It can be given negative sign. When it is given negative sign, when the system releases energy. When the system releases energy to the surroundings. In the first case, energy was got from the surroundings. Here in this case, reverse of first case. So here Q is positive. Here Q is negative. Now after Q, coming to W. When is W positive and negative? W is positive when work is done on the system. Work done on the system. When work is done on the system, W is given positive sign convention, and it is given negative sign when work is done by the system. So these are some sign conventions of W and Q, and that is all for today. Thank you very much.